In this next section, we're going to look at the law of sines. And everything you've done so far in trigonometry has been with right triangles. A triangle that's got a 90-degree angle, and we've used this opposite, adjacent, and hypotenuse relationship to describe sine, cosine, and tangent. But now we're going to get into triangles that are non-right triangles. And these are called oblique triangles. Oblique, which means they don't have a right angle, which means then you don't have a hypotenuse by the same definition that we talked about back in geometry. So one of the first skills we want to work with is we want to solve an oblique triangle when we're given either a side and two angles or an angle and two sides, and we want to find all the different pieces. So we're going to use the law of sines. And the law of sines is basically a large proportion that says the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is then also equal to the sine of angle C over side C. And I might look at that and say that's pretty complex, but realistically we're only going to be dealing with two fractions at a time. We might just be dealing with sine of A over A equals sine of B over B. Or it might be sine of B over B equals sine of C over C. Or we might not have the middle piece right there and just deal with sine of A over A equals sine of C over C. So realize that you're only going to be using two of those three fractions at a time. But all the sides and angles have this proportional relationship to each other. So we can use the law of sines when we know two angles in any side or two sides in any angle opposite them. So the angle, side, angle, and the side angle relationship you learned in geometry. So first one, we're going to solve triangle ABC if angle A is 38 degrees, angle B is 64 degrees, and angle C is, or side C is 81 units. So the first thing we probably want to do is just draw a picture so we know what we're looking for. And I really don't know if this is going to be drawn to scale because I don't know all my angles or I don't know all the sides. So I'm just going to fill in some pieces that I do know. We'll call this side angle A, and we know angle A is 38 degrees. And then we'll call this side angle B, which is 64 degrees. And I can see right now that's not perfectly drawn to scale because my 38 and 64 degree angle look pretty similar. And then up here would be angle C, which then means this is going to be side C because the side is directly opposite the angle. This would be side A, and this would be side B. And I know side C is equal to 81. So here I can see I've got an angle-side angle relationship, which is one of the things that I would use for the law of sines. So let's start finding all the different pieces of the triangle. The first one we can find is probably the easiest is angle C. We know that a full triangle is 180 degrees. So angle C is going to be 180, which is the full triangle, minus angle A and angle B, which is going to be 64 degrees and 38 degrees. And that's going to give me 78 degrees for angle C. So I know this right here is going to be 78 degrees. Now I need to find side A and side B. And for that I'm going to need to use the law of sines. Now the question is, what pieces am I going to use? Well, if I know that I'm going to be finding side A, and I know side A, I can't have another variable in my equation. So I have to take the ratio that I know everything for, which in this case is C and C, angle C and side C. If I were to have chosen angle B and side B, you can see I've got an unknown right here. So if I would have plugged in sine of A over A, which is my unknown for the length, and then sine of B over another unknown, I wouldn't be able to solve it. So I have to go with my known side and my known angle, so sine C over C, and I'm going to use my known angle and my unknown side for A. So the sine of 78 degrees over 81 is equal to the sine of 38 degrees over A. And since I've got a proportion, I can cross multiply and solve. So A times the sine of 78 degrees is equal to 81 times the sine of 38 degrees. Divide both sides by the sine of 78 degrees. So A is 81 times the sine of 38 degrees divided by the sine of 78 degrees. I plug that into our calculator, making sure we're in degree mode, and we get a length of 50.983, rounded to 3 decimal places. So I know side A here is going to be 50.983. We'll do the same approach with the second side, that's the unknown. And this time I could use sine of C over C or sine of A over A since I know both pieces. But the better choice to use is sine C over C. And the reason for that is sine of C and side C are exact values. Remember here we rounded for side A. So we probably don't want to use that. I mean, if we look at our answer, we're going to see that they're very close because we rounded 3 decimal places. But it's good math practice to use the exact values we know. So we'll use sine of C over C is equal to sine of B over B. So the sine of 78 over 81 is equal to the sine of 64 over my unknown, which is B. Once again, B times the sine of 78 degrees is equal to 81 times the sine of 64. Divide both sides by the sine of 78 degrees. And rounding to 3 decimal places, we see side B is going to be 74.429 units. So B is going to be 74.429. Now, before we finish this problem and say we're done, let's just do a quick check to make sure we didn't mess up on anything. And we can do a quick check just by checking our angles and our sides. Remember, one of the rules from geometry for your triangles was that the smallest angle was across from the smallest side, the middle angle was across from the middle length side, and then the largest angle was across from the longest side. We should just do a quick check and make sure that lines up here. Here, angle C is my largest, 78 degrees. It's across from the largest side, which is 81. The smallest angle is 38. Across from it, the smallest side is 50.983. And so then the middle one, 64, is the middle length, 74.429. So that looks like we've got a good type of solution for that triangle.